Hey everybody, in this video we are going to solve some quadratic equations by taking the square root. Okay, so these are called quadratic equations because the greatest exponent is 2. And anytime the greatest exponent is 2, that means there will be 2 solutions. Now in each of these equations, we're going to have a second power on the variable, but no first power variable. So it won't be like n squared plus n, it'll just be n squared. Okay, so when we have n squared but no n to the first power, we want to get that n squared term by itself, which it is here. So we're going to do a few here that are just one step. Our first step and our only step will be to take the square root of both sides. So we get n equals the square root of 5. But I said there would be 2 solutions, and there are 2 solutions because there's the positive and negative version of the square root of 5. And when we do this next one, we'll talk about why that is. So our 2 solutions are the square root of 5 and the opposite of the square root of 5. Number 6 here, sorry we're not really going in order, it goes down each column, and we're just going to go left and right. So here we will do the square root again, so we get q equals plus or minus the square root of 49. Now this time the square root of 49 can be simplified. The square root of 49 is 7. So we get q equals plus or minus 7. Now why a positive version and a negative version? Because if I plug this back into the original equation here, 7 squared is 49. Negative 7 squared is also 49. So both the positive and negative square roots will satisfy this equation. Next up, k squared equals 6. So we do the square root and we get k equals plus or minus the square root of 6. Now that square root, just like the one above, does not simplify, so we're going to leave it just like that. K equals plus or minus the square root of 6. Once again, a square root, so we get b equals plus or minus the square root of 24. Now this one can be simplified, but not quite like this one was simplified because 24 is not a square number. But 24 is the same as 6 times 4. So this is the same as plus or minus the square root of 6 times 4. Now 4 is a square number. The square root of 4 is 2. So b equals plus or minus the square root of 4 is 2 times the square root of 6. So this is our simplified solutions. Okay, now we're going to turn the page and we'll have some problems with an extra step. Now still we have w squared but not w to the first power. So when I just have w squared and not w to the first power, I want to get this term by itself. So minus 10, so we get w squared equals 20. And then take the square root, so w equals plus or minus the square root of 20. And 20 is a square root that can be simplified. So it's plus or minus the square root of, and 20 is 5 times 4. And the square root of 4 is 2. So w equals plus or minus 2 times the square root of 5. Okay, then g squared plus 6 equals 54, so minus 6. Okay, so g squared equals 48. Okay, and then the square root on both sides, and we get g equals plus or minus the square root of 48. Now this one can be simplified also, so we get g equals plus or minus the square root of, and we want to know a square number that goes into 48. And it would be helpful to get the biggest square number that goes into 48, and that happens to be 16. 16 times 3 is 48. So g equals plus or minus the square root of 16 is 4 times the square root of 3. Here we will subtract 5, so we get s squared equals 10. The square root on both sides, we get s equals plus or minus the square root of 10. Now 10 is 5 times 2 Neither of those will be square numbers, so the square root of 10 cannot be simplified. Here, plus 3, so we get q squared equals 16. Square root on both sides, so q equals plus or minus the square root of 16. And 16 is a square number. The square root of 16 is 4, so q equals plus or minus 4. Okay, now let's try some with yet another step. So we have 8b squared minus 7 equals 57. And once again, we have b squared, but not b to the first power. So we want to get that b squared by itself. So plus 7. So we get 8b squared equals 64. Then we can divide both sides by 8 and get b squared equals 64 divided by 8 is 8. And then the square root. So b equals plus or minus the square root of 8. Okay, so I'll bring that up here. So b equals plus or minus the square root of 8 is 4 times 2, and 4 is a square number. The square root of 4 is 2, so b equals plus or minus 2 times the square root of 2. Here we will add 10. So we get 4z squared equals 400. We will divide by 4 and get z squared equals 100. And then the square root, z squared equals plus or minus the square root of 100. This shouldn't be z squared anymore. I did the square root to get rid of that squared. So z equals plus or minus the square root of 100. And 100 is a square number. Square root of 100 is 10. So z equals plus or minus 10. Here we will add 6. So we get 3m squared equals 90. We'll divide by 3 and get m squared equals 90 divided by 3 is 30. Now square root on both sides to cancel out squared, and we get m equals plus or minus the square root of 30. Okay, so 30 can be broken up into 6 times 5, and 6 is 2 times 3. It could be broken up into 15 times 2. But we're not going to be able to break it up into any square numbers. So the square root of 30 is not going to be able to be simplified. Okay, so then here we will subtract 10. We get 2b squared equals 14. And divide by 2, and we get b squared equals 7. Take a square root to cancel squared, and we get b equals plus or minus the square root of 7. And the square root of 7 cannot be simplified, so b equals plus or minus the square root of 7 is our final solution.